Graph using intercepts. So we're on page 225, and we're going over how to graph using the standard form and basically two easy to figure out points, the x-intercept and the y-intercept. Now the x-intercept is the point at which the graph crosses the x-axis, and in this case here crosses the x-axis there, and the y-intercept is where it crosses the y-axis, which is right there. So basically, if you can plot those 2 points, then you can have a line. And in this example here, if you look closely, you can see it has the line which it says 2x plus y equals 6. And what they did was they figured out when x is equal to 0, what the y value is. And that's why the y value is going to be 6 there, because that there is where it crosses the actual y-axis. So that's actually the y-intercept. And then over here, when they plug it in when y is equal to 0, it's where it crosses the x-axis, and there you have 2x is equal to 6. And then when you do that, you end up with x being equal to 3. Don't worry, we'll do a few more of these, and I think it will make more sense then. So let's go ahead and look. So finding the intercepts of the graph of an equation. Here is the equation we're going to be working with. So there's the equation, and the first thing we're going to do is we're going to solve and try and figure out what the x-intercept is. To figure out what the x-intercept is, the y value has to be 0. So if we do that, then we do 2x plus 7 times 0 is equal to 28. So it's just going to be 2x is equal to 28. So x is just going to be equal to 14. So the point at which it crosses, at which is the x-axis, is going to be 14, 0. So now we're going to do this with the y-intercept. And for the y-intercept, it's the same thing. We still use this equation, but instead 0 is going to be the x value, because that means it's going to cross the y-axis when x is 0. So now we just, again, it's going to be 7y is equal to 28. So y is just going to be equal to 4. And so the point at which it crosses the y-axis is going to be 0, 4. Let's do a couple more. So here's another equation, and if we want to figure out what the x-intercept is, then we have to plug in 0 for the y value. And so what we do is 3x plus 2 times 0 is equal to 6. So 3x is equal to 6. So x's value then is going to be equal to 2. So the first point, this is the x-intercept, it's going to be 2, 0. The y-intercept, we again take this equation, and now we're going to plug in 0 for the x. When we do that, it's plus 2y is equal to 6. And so now we got 0, 2, 0 for this term here, so 2y is equal to 6. So y is going to be equal to 3. So our point for our y-intercept is going to be 0, 3. So here are our two intercepts. There. You can always tell it's an intercept because that's 0. So let's try one more. First of all, we're going to go ahead, get the x-intercept. That means that term has to be 0. So negative 3x plus 5 times 0 is equal to negative 15. So negative 3x is equal to negative 15. So that means x, divide both sides by negative 3, is going to be equal to 5. So that first point is going to be 5, 0. That's our x-intercept. Now we're going to take this equation again, and this time we're going to plug in x being 0 because we're going for the y-intercept. So it's going to be negative 3, 0 plus 5, y is equal to negative 15. And yes, I did just fix that. So negative 15. So Now this is going to be 5y is equal to negative 15. So divide both sides by 5, you get y is equal to negative 3. So our second intercept is going to be this right here. So this one is going to be our y-intercept, and this one here is going to be our x-intercept. So that's how you did this problem here and this problem. So now we're going to move on to the next page. And here what's happening is you're being asked to graph this equation. And the easiest way of doing that is probably by doing the intercepts. So let's put down the equation. So you can see here x plus 2y is equal to 4. So to figure out the y-intercept, we're going to go ahead and make x be 0. Well, actually, let's do the x-intercept first. So we've been doing before. So we're going to go ahead and make that into 0. So x plus 2 times 0 is equal to 4. That means x's value is equal to 4. So now we're going to take this equation again. So the point is going to be 4, 0. Now for the y-intercept, we're going to make x be 0. So we're going to take that equation. 0 plus 2y is equal to 4. So y is going to be equal to 2. So it's going to be 0, 2. And then all that happened was these are plotted right here on those points, and then you just connect the dots. For this next one here, what's happening is you're identifying where it crosses. And if you look really closely, you can see it crosses the intercepts for the x and the y-axis. For the first one, for the x-axis, it crosses at 2, 0. That's the x-intercept. And the y-intercept, it crosses at 0, negative 1. So that's 0, negative 1 right there, and that's 2, 0 there. So looking at this example here, so that's our equation for this problem here. And if we want to figure out the x-intercept, then we're going to make this part here 0, so 6x plus 7 times 0 is equal to 42. So in that case there, 6x is going to be equal to 42. So x is then going to be equal to 7. So our first point is going to be 7, 0. That's going to be, in that case there, that's going to be our x-intercept. And then we're going to just take this equation and bring it down there. We're going to change it. Now we're dealing with the y-intercept. And it's the same thing here. So now it's 7y is equal to 42. So divide both sides by 7. So y is just going to be equal to 6. And so then our y-intercept is going to be that. And so that's how you do that. And then if you look really closely at here and here, you can see that the point where it crosses the y-axis, that would be the y-intercept, is going to be 0. And then it looks like it's about 2 for that there. And then at this bottom point, it's going to be, well, it's negative 1, 2, 3, 4, negative 4, 0 for that bottom part. And this has some key information there that you should really review if you're confused at all about x and y intercepts. So this is now a problem where it talks about how this can be used. It says here, you are helping to plan an awards banquet for your school, and you need to rent tables to seat 180 people. Tables come in 2 sizes. Small tables seat 4 people, and large tables seat 6 people. The situation can be modeled by the equation 4x plus 6y equals 180. So if that's the case, what ends up happening is then you're being asked, it says here, where x is the number of small tables and y is the number of large tables. Find the intercepts of the graph the equation. Graph the equation and list 4 possibilities. So all we're going to do is, for here, we're already figured out the intercepts. All it's going to be is the x-intercept is going to be 45 and the y-intercept is going to be 30. It's the same way we did those other problems, so I'm not going to do those. But then you're graphing them, and this is the graphing of that. And you're connecting the dots there. Each of them are going up by 5 each time. And then you can see that they added a couple more points here. where it made an easy sort of recognizable point where it went across. So it says here, so those are four possibilities, and the four possibilities are going to be listed over here. So those are all the possibilities in this column here, this column here. That's the amount of small tables, and this column here, that's the amount of large tables. And then the rest of the problem is, it says here for the second part, it says here if the small tables cost $9 to rent and the large tables cost $14, of the four possible combinations of tables given in the example, which rental is least expensive, and then explain. So all you're going to do is here you're going to multiply any number in this column here. You're going to multiply that by 9, and then you're going to add to, up in this column here, this is going to be multiplied by 14. So then you can figure out which one is the best deal. And this one here is just another example here. They're talking about a submersible in the ocean, and it's starting at an elevation of negative 13,000 feet, or 13,000 feet below sea level. And it's going to ascend at a rate of about 650 feet per minute. And the elevation is going to be done by this equation here, which is E is equal to 650 times T minus 13,000. And so to find the intercepts, you're just going to graph it here. And as you graph it, you got to determine how you want to set it up. In this case here, they set up thousands or negative 2,000 and for each of these individual lines that are here. And then it was up by 2 for each of these lines here. And so then they just graphed it after they found the intercepts. And then you can figure out the domain and the range for how long it will take to get all the way up there to being 0 in terms of the elevation. And what the range is it's listed down here in the domain, because obviously the range of the function is going to be negative 13,000 feet to 0, because that will be sea level. But the domain, that's what the amount of time, that's going to be from 20 to 0 minutes.